All right, so last time we had gone through section 1.7. So today we're going to start up in section 2.1. And section 2.1 is on linear functions. In fact, almost all of the things we are going to cover in chapter 2 are linear functions. Okay? Linear functions, linear equations, all that kind of stuff. All right. So 2.1, 2.2, 2.3, 2.4, all of that is going to be linear functions, linear equations. Let's see. Now, the first thing we need to talk about is the idea of linear. So what does linear mean? What is a linear, let's say, equation? The big idea about linear equations, let's just say, let's keep the two variables here. All right, so we're going to keep the two variables. A linear equation in two variables is one where each variable can only be raised to the first power. So we can only have first powers, can't something squared or anything like that. And then they're not multiplied by each other, and we're not dividing by any variables either. Okay. So variables. I'm just going to say in numerators. Let me rephrase that. Variables to the first power. No multiplying variables times another variable. No variables in the denominators. All right. And that's a lot of information. So what people generally do, instead of saying we have to have this, 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 and this, they just say a linear equation can be written in this form, right? Simplified and rewritten in a certain form. So that's the easier definition. A linear equation with variables, let's say x and y. Is an equation which can be written let's write it this way. Ax plus by equals c, where a, b, and c are real numbers. So ax plus by equals c can be rewritten that way. Doesn't mean it's written that way right now. It just means it can be manipulated, simplified, reworked to be made to look like that. Okay. Hopefully that makes sense. So if I say, let's go through this, which one is linear and which ones are not, and I give you something like 5x minus 4y equals 17, that's already in that form, right? So that one's very obvious that that is linear because it looks like that. But also, if an equation looks like this, y equals 1/2 x minus 4, well, it's not in that form right now, but it can be easily rewritten into that form, right? By subtracting 1/2 x from both sides, and then you get the x term over here. I'm not gonna do that, I'm not gonna rewrite it, that's not worth my time, not worth your time. What I'm really looking at is that the x variable and the y variable are to the first power, and they're not multiplying each other, they're not dividing by each other, you know, that type of thing. So that's what I'm really looking for. That the x and y are in the first power. And once you do that, then you see things that are and are not linear. If I took like x squared plus 5x minus 7 is equal to y, that is not linear because of this x squared term. This one, we may think, well, all the x's and y's are raised to the first power, but because we have x times y here, that's not linear either. Okay, this is two variables being multiplied, so that's not linear. Something like that. Now that's fairly involved. Is that one linear or not? Linear. All of the x's and y's are being raised to the first power, and there's really no place I'm multiplying by a variable times another variable. So, yeah, this one's also linear. All the x's and y's are raised to the first power, or no place I'm multiplying variable times variable. So that's linear as well. So linear equations are nice. To deal with. Okay. The nice thing about linear equations in two variables So we got linear equations in two variables, x and y. Are going to have graphs that are straight lines. So each linear equation has a graph that's a straight line. Okay. So if we went to graph this one, or this one, or this one, you'd end up with a straight line of some sort. Okay. Not this one, also not this one. Okay. But anyone that's linear is a straight line. In fact, let me go ahead and take a look at Desmos, and I'll graph a couple of things with Desmos. All right. Nope. So if I have 5x minus 4y equals 17, there you go. Get a straight line. Okay. What about the one that was not linear where we had x times y? Let's take a look at that. 3x plus 4xy. Or actually, x times y. Let's do that just to make sure it's right. Plus 7y equals 8. Notice that x times y piece forced me to have like an asymptote of some sort. Weird, huh? So the x times y, if you're trying to graph it, not gonna turn out well. Not gonna turn out as a straight line. That's why we don't want to include that feature with linear. Okay. But regardless of how complicated a linear equation is, we're gonna have a straight line. Okay. Now the nice thing about straight lines is that they are either always increasing or always decreasing. If I went, let's do y equals, I know this is gonna be y equals negative 2x plus 5, that's decreasing the whole time, right? The red line here is increasing. As we move left to right, points are going up. As we move left to right on the green line, the points are moving down. Okay. So we can see that obviously some linear equations yield lines that are increasing, some yield lines that are decreasing. You could also have a constant line, which is just straight horizontal. All right, that's a special line. In fact, you get that by just having y equals, let's say 3. Y equals a number, gives you a horizontal line. And you get a vertical line by taking x equals some number. And then graphing it in 2 dimensions. That makes sense? So that's that. So we can see that certain lines increase, certain lines decrease. Technically, you can have constants, but if they are linear, they're going to do one, always increasing, always decreasing, or always constant. All right, they're going to do one thing. That's why, again, linear things are nice to deal with. Now, there's a lot of different ways we can approach this in terms of going from linear equations to linear functions, but I just like a function notation versus a y exchange, and we've seen this before. So all linear equations can also be written as y equals mx plus b if we have both x and y as our variable, all right? So if we have both x and y as our variables, that's kind of the way that works. This is a traditional called slope-intercept form. I'm sure people have. We'll get to that in a second. So that's our slope-intercept form. The ax plus by equals c, that's actually standard form, but we don't use that one as much as slope-intercept form. And this all linear equations can be written like this. This moves us to create linear functions that look like this, and we're just going to do the function notation to replace the y. Okay, so all linear functions can be written as f of x equals mx plus b. Now, I didn't say this earlier, but the m and the b are just real numbers. So when we deal with linear functions, we're going to deal with linear functions. And if I talk about slope-intercept form of the function or slope-intercept form of the equation, I'm really talking about the same thing. Okay, so technically slope-intercept form is this one, but I'll oftentimes just as habit call this also slope-intercept form because it's just a y f of x exchange. Right. So I've mentioned slope a couple of times. Slope tells me how fast my line is increasing or decreasing. Slope tells how fast line is increasing or decreasing. And the slope is always given as a change. And y divided by a corresponding change in x. We'll take a look at the lines I had graphed. Okay. All right. So I want you to focus on this green line first. Back, let me shut that one down. So there's the line I'm focused on. We say slope is a change in y divided by a change in x. Now, what we mean by that is a change in y from going from one point on the line to another point on the line. So for instance, if we go from this point 0.5 to the point 1,3, what you should see is that the y value decreased by 2 as the x value increased by 1. So the y value went from 5 to 3. It was a decrease of 2. When the x value went to the right 1 unit. So a decrease of 2 is a negative 2 divided by moving over 1. So that's a negative 2 divided by a 1 as a slope. Now, did it have to just be this point in particular? Of course not. You could have, let's say, went to the point 4, -3. So we start at 0.5. And then we go to 4, -3. That's a decrease of 8 from 5 to -3 in the y direction, and an increase of 4 in the x direction. Now, if you think about that, I said my slope the first time was -2/1. And when I chose 2 other points, it came out to -8/4. Notice that both of those reduced are going to be the exact same thing. So no matter what the line is, all linear functions are going to have constant slope. All right? All linear functions are going to have the same slope throughout the entire, wherever it's located. Wherever you're located on that line. And if you write your linear equation in slope-intercept form, or your linear function in slope-intercept form, that slope is just the m in the equation. Okay? And slope intercept form. M is equal to the slope. And you probably saw I started at 0.5 each time. my equation was y equals negative 2x plus 5. So we had the slope of negative 2 we found each time. That 5 corresponds to the point 0.05. And so also, no matter what this value is, the b value in slope-intercept form, 0b is going to be the y-intercept of your line. So slope tells me how fast lines are increasing, decreasing. It's given to me if I write a function in slope-intercept form, or if I write an equation in slope-intercept form. It's given to me by that m. And furthermore, negative values in the m mean that as you move from left to right, the line is decreasing, right? So these negative ends or negative slopes are decreasing lines, and positive slopes mean that your line is increasing. Now I'm going to erase this real quick. That's pretty straightforward, hopefully. So let's identify the slope of each function. And then state if the line is decreasing or increasing. I should say or constant. By the way, when would we get a constant slope again? What would that mean? Constant.
And it's just like y equals like 3 or something.
Exactly, like y equals 3. And in this equation, what would that mean for the m? That would be the m was essentially 0. This term goes away. All right. So slope of 0 means the line is constant. Exactly. So like y equals 3, this goes away. Y equals 4, that goes away. Okay, so let's take a function. F of x equals negative 1/2 x plus 4. Slope here is what?
Negative 1/2.
Yeah, negative 1/2 or negative 1/2. Moodle may ask you to write that as a decimal of like negative 0.5. I'm not sure if it's going to ask for a decimal or fraction. Probably might ask you for a decimal. There's certain, this is a kind of a weird thing in Moodle, but there's certain types of questions where when you program it in Moodle, they don't like fractions very well. And then there's certain questions that are just fine with fractions, so.
I have a question on that.
Yeah.
So like if it's saying to round a few decimal places and say it's like 2/3, would that be like 0.67 or 6/6?
0.67, yeah, so, yeah, 6 would round up.
Same with like 1/3, 3/4.
Well, 1/3 would be 0.333, so it'd be 0.33.
Okay.
Yeah, so 1/3 would be 0.33 with standard rounding, and 2/3 would be 0.67 standard rounding. So slope is -1/2, that means the line is decreasing. Or this line is decreasing, right? And also, if we wanted to, the y-intercept is 0,4, right? We weren't asked to do that, but we could do that if we wanted to. Okay. If we have, let's do another g of x equals 3/4 x plus 8. Well, in this case, the slope is simply 3/4, or again, type 0.75 in the Moodle. And because it's positive, the line is increasing. H of x. H of x is equal to -5x minus 1. Slope is -5. Line, since the slope is negative, is decreasing. That works. Fairly straightforward. Now, if we're ever in a situation where our line is not in slope-intercept form, or our function is not in slope-intercept form, but I know it's linear, just simplify until it's in slope-intercept form, or sometimes rewrite. So for instance, let's say I have 3 times x plus 4 minus x minus 5. Well, all I'm gonna do is simplify that right-hand side by applying the distributive rule and then combining like terms. And when I do that, I get 2x plus 7 eventually. Slope is a positive 2. So the line is increasing. And now that we've simplified, obviously 0,7 is the y-intercept as well. Doesn't always have to involve a lot of manipulation. I don't want to do that. Let's do some people might get thrown off by something like that, 13 minus x. Remember, slope-intercept form Technically, the x comes first. So if I were to rewrite this, by just flipping the order, negative x plus 13. Slope there is -1. The line, therefore, is decreasing. Negative slope, decreasing line. So don't get thrown off by that. And in fact, a lot of people won't even rewrite this because this is just that in a different order. So if you know, hey, the coefficient of the x is your slope, you can see that this one is -1, y-intercept is 0, 13. You can see that in this one, then you're good to go. Okay. Now, a lot of the next couple of sections will be finding equations of lines and using certain features of lines. And one of the things we're going to use, not only in this section, but in future sections, is how to find slope of a line given 2 points on that line. So in other words, the line goes through a first point and a second point. The first point we're going to call x1, x1, y1. So that's just the x value of 0.1, the y value of 0.1. And the second point we're going to call x2, comma y2. That's just the x value of 0.2, comma the y value of 0.2. Right? Well, we go back to this slope. Is supposed to be the change in y divided by the change in x. Sometimes that's written in shorthand as capital delta y over delta x. That's change in y over change in x. So that's the shorthand for change in something. That's the change in the y value divided by the change in the x value. We're not going to use a lot of delta notation in here, but in Calc 1 you use delta notation. So at least I'll mention it here. Well, what's the change in y? The change just means the difference in the y values. So usually, traditionally, we start with the y2 and subtract the y1. That's the difference in the y values. The change in x is the difference in the x values. And again, if we started with 0.2, 0.2's y value, we'll start with 0.2's x value in the denominator. So there you go. And you'll often see this written shorthand as m equals y2 minus y1 divided by x2 minus x1. Okay. So let's just apply this. What is the slope between, let's do this point, 1, 8 and 3, 18. So we have 2 points, change in y. Again, I usually call my point that comes second, my second point that comes first, my first point. So if I talk about which one of those, the 1/8 or the 3/18 is the first point, which one's the second, I call the 1/8 first point, 3/18 second point. The nice thing about this equation is that if you did the opposite, if you called 3/18 your first point and 1/8 your second point, you'll get the same answer that I got. So it doesn't matter which one you call your first point, which one you call your second point. I just pick one and go with it. So 18 minus 8 is the difference in y values. 3 minus 1 is the difference in x values. Do your subtraction first. And so you get a slope of +5. Obviously, we've seen slopes can be kind of ugly fractions. We've seen slopes can be all kinds of other stuff. But this one came out to a nice whole number. I want you to do this one on your own. What is the slope between the following 2 points? Let's say -3, 7, and -2, -4. It shouldn't take super long. I'll call this my second point, this one my first point. So -4 minus 7 divided by -2 minus -3. I get -11 on top. And then a +1 on the bottom. Be careful to minus the negative things when you're subtracting a negative. Other than that, pretty straightforward. Again, I got a nice integer this time. Could have ended up with an ugly fraction if we had different numbers. Right? And that's the same thing as average rate of change. So slope We're good. Now, finding slope is one tool that we're going to use when we find equations of lines. All right? So we're gonna find some equations of lines. And we'll find slope with those. Before we do that, though. You know what? No, we're good. Yeah, we're good right now. We'll keep, I'll keep it the same. So I don't confuse 2, 1, and 2, 2. I was gonna mix up 2, 1, and 2, 2. They're very, very closely tied. So let's start finding equations. So we're gonna find linear equations. I want you to think about a linear equation. A linear equation is always written as y equals mx plus b. Or we can always write a linear equation as y equals mx plus b. As long as we have both x and y terms. So what do I need to know if I'm going to write y equals mx plus b for a particular linear equation? Just need the m and I need the b. So that's what we're going to do. Every single finding linear equations, we're going to try to start off finding whatever m I need. There's going to be multiple ways of doing that. And then we're going to use some other piece of information to find the b. So to find linear equations, all we need to do is find the slope. And I'm just going to say right now that there are many ways to do that. And then find the b, which is the y value of the y-intercept. And we're going to do that the same basically every time. Once you found your m and your b, then you can just write the equation. All right. Does that make sense? Let's start with an easy version. Find the linear equation with slope of -3 that goes through 0.111. So what I like to do is I like to start out and just rewrite y equals mx plus b. So that I can remind myself I need to find the m and I need to find the b. And I almost always find the m first. Now I said this one's pretty straightforward because I know that m stands for slope. And therefore, if it says slope of -3, my line has slope of -3, that means my m is simply -3. I don't have to do any calculations. Now I know that the equation is going to look like y equals -3x plus some number that I haven't figured out yet. Now, when we say a line goes through a point, what we actually mean is that if we plug in that point, it gives us a true statement. That is a point that works in the algebraic equation. So that's what the graph of a line is, right? A bunch of points, which when you plug them into the equation, make that equation true. So if plugging in 111 makes this equation true, I can plug in 111 and then keep the equal sign. Because it's going to make it true, so it's going to keep both sides equal. So plug in the point 111. Now be careful here, some people will flip-flop the x and the y. But remember, 1 is the x value in the Cartesian coordinate system. 11 is the y value. Once that's all simplified, I can solve for b. And we get a b of 14. So I found the slope, found the b. Last thing I need to do is write the equation. In this case, my equation is y equals -3 times x plus 14. And that's it. That's the whole thing. So we always find the slope first. Then we use that point, plug it in. That'll give us our b. And again, plugging in that point is simply a fact of going through the point means the equation becomes true if you plug in that value, that point. All right, let's do something like that again. Let's find the linear equation with slope, let's say a positive point, let's do a positive 1.8 that goes through the 0.4, comma 7.3. I want you to try this on your own. Other than having decimals, positive versus negative numbers, it's the same process as what we just did. Alright, so let me go through this. First off, it tells me the slope is 1.8. That's my M. So I know my equation is going to, in general, look like that. Y equals 1.8x plus b. Since the line goes through for 7.3, I can plug in that point. Again, be very careful that you plug in the 7.3 into the y value and the 4 into the x value. Since we go through that point, makes my equation true. I can do that. 1.8 times 4 is 7.2. When you subtract 7.2 from both sides, you get 0.1 or 0.1. And so my equation is y equals 1.8 times x plus 0.1 or plus 0.1. It doesn't matter how you write that. Moodle will accept 0.1 or just 0.1. Is that right? Nothing too crazy there. Good. Now, we just got done doing slope between 2 points. So let's use that as well. We're going to find the linear equation that goes through 2 points. In this case, let's say 1, 4, the point 1, 4, and the point 5, 7. Now the process is going to look really, really similar. The first thing I always do in these types of things, in these situations, is I say, what's the slope? Because I'm given 2 points on the line, I can find the slope by taking y2 minus y1 divided by x2 minus x1. The y value of the second point minus the y value of the first point, all divided by the x value of the second point minus the x value of the first point. So in our case, that's 7 minus 4, which is going to be 3 in the numerator. In the denominator, we have 5 minus 1, which is going to be 4. So the slope is 3 over 4, 3/4 or 0.75, however you like to write it. I'll leave it as 3/4 right now. That means my line is going to be y equals 3/4 times x plus some b. Now, how do I find the b? Well, in the last example, I plugged in a point. In this example, I have 2 points. Does it matter which one I plug in? No, you can plug in either. So if you plugged in 1.4 and your neighbor plugged in 5.7, you'll get the same beat. But don't mix and match, don't plug in like the one with the 7. You either plug in the 0.14 or the 0.57, whichever one. I'll plug in 5.7, I guess. Now, depending on how you want to write this, 3/4 times 5 is like 3.25, I believe. I do that in my head, but 15/4. 7.5, sorry. I knew that was gonna happen. Gonna do something wrong in my head. 3.75, excuse me. And then subtracting 3.75 from both sides, that's what I think I was going with this. It's 3.25 is the B. Yeah, that's what I'm looking for. You can also write that as a fraction if you like. Again, your calculator automatically exchanges things between fractions and decimals. So my equation is y equals 3/4 x plus. Now, depending on how you want to write this, if you want to write this as all fractions, that's fine. 13/4 is the fraction version of 3.25, that's fine. Or if you rather, I think Moodle will ask you for the decimal versions. So that would be 0.75x plus 3.25, whichever one that Moodle asks you for. About this one. I want you to go ahead and try this one on your own. Find the linear equation through the points 5, 3, and 82. Again, using that same technique that we've been using. Those same techniques that we've been using. Alright, now this one can be a little bit problematic. If we don't know one thing, so. When you do this. We'll go -3 over 8 minus 5, just like we normally do, and we get -1/3. Now, the thing about fractions like -1/3 is that when you look at the decimal of -1/3, they go on forever, right? If I were to round right now and call this -0.33, then a lot of the rest of my problems is gonna get screwed up by a little bit, by that rounding issue. So I'm not gonna round until the very, very end. That makes sense? So if you're in this situation where you have a slope of -1/3 or 2/3 or 5/7 or, decimals that go on and on and on, use the fraction version of the slope until the very, very end. Now, it didn't matter so much over here because 3/4, if you use 0.75, 3/4 is exactly 0.75. So you would have been just fine using the decimal version because it stops after 2 decimals. Here, we have the repeating decimal, so that throws in the issue. So don't round until the very, very end, until your very last step. I'm gonna plug in A2. If you would have plugged in 5/3, that would have been okay as well. Add 8/3 to both sides. Again, notice I'm not rounding that 8/3 yet. If I take 2 plus 8/3, I get 4 2/3. Or 14/3. All right, 14/3 here. Now, technically, the exact version of the equation is -1/3 x plus 14/3. That's the exact, that's the precise version. In Moodle, it'll ask you for rounded numbers. And so if you're gonna do rounded numbers, that's gonna be -0.33 x plus 14/3 is 4.67. But again, notice I didn't round to the very, very end. I wasn't rounding in here all the time. So if you do come across an equation like that, just wait till the end to round. Any questions about either of these things? These two techniques, or I should say, not just two, but the technique where we find slope through 2 points and the technique where we are just given slope and find the equation, those can be used to do word problems as well. Okay. So let's say the height of water and I should say depth, but that's okay. And a well is growing linearly there's a well on day 3, the height was 14 inches. And on day 5, the height was 20 inches. Let's write an equation. For the height of water on day X. Height of water, we'll call the height of water, we'll call that the letter H. On day number X. We'll call X the day. I don't want to use D because that can look like something else. Put a D though if you want. On day D. Day number D. Whatever letter you want, you can use, obviously. So what is this really? This is a word problem version of what we just did. We have 2 points. And if we go day, comma, height, for our 2 points, on day 3, the height was 14. And on day 5, the height was 20. H equals mx plus b. Guess you could have used height of water as being y too. Again, the word problem is going to tell you which variables to use, whether it's x and y or h and x or h and d or whatever the values are. But it's the same principle. Here we have 2 points. So let's find the slope of those two, of the line between those 2 points. Looks like the slope is 3. Normally I do y equals 3x plus b, but now they're asking me to use h for my variable instead of y. And just like we did earlier, plug in one of those points. So let's plug in 520. I ended up getting a B of 5. So H is equal to 3 times X plus 5. And then if I wanted to answer a question like, well, what's the height on day 2? After I found that equation, I can simply say, well, X stands for the number of days. H is the height, so plug in 2. Looks like 11. This was all in inches, so 11 inches on day 2. Any questions about that process? Again, it's the exact same process we were just doing, except now the 2 points are disguised inside the word problem. And by the way, we've done this with the 2 points disguised in the word problem. You can also do the other version. Which says let's say this is probably not a good one, but let's say a pine tree is growing at a rate of 1.5 feet per year. When it was planted, it was 6 feet tall. Write an equation. For the height. Okay, we'll use H for height of tree after, let's say T years for time. Does that work? Well, growing at 1.5 feet per year, as long as our variable is years. Right, y equals mx plus b. Also in this case, h equals m times t plus b. Saying we're growing at a rate of 1.5 feet per year just means that my slope is 1.5. When it says it was initially planted, initially planted means time of what? We'll call that time 0 since it was planted, right? So it's planted at time 0, planted. 0, we have the 0.06. That's actually gonna be my b, isn't it? Because that's gotta be y-intercept always has x value of 0. But we'll go through that. We'll go through it all. You end up with a b of 6. So we get the equation h equals 1.5 t plus 6. Now, the one thing I will mention when you're writing these equations into Moodle is that you need to make sure that you use the variables that they use. So if they tell you to use variable h and t, and they're both lowercase, make sure you use lowercase h, lowercase t. If they're both uppercase, make sure you use uppercase. So be real careful about those types of things. But other than that, pretty straightforward. And if you want to find the height after 10 years, you just plug in a t of 10. If you want to find the height after 5 years, you plug in a t of 5, right? I'll go into that. So finding these equations has some really nice applications, right? Really nice applications. Whether we're given sort of 2 points in a word problem, or whether we're given like this one, we're just given the slope and we recognize the slope. All right, so that's all we want to do. That's it for 2.1. Now we're going to move on to 2.2, which is essentially graphs of linear functions, which really has a lot of overlap with 2.1. Okay. Now, in terms of graphing linear functions, we're going to do a couple of things. Trying to think of which one I want to do first. Okay. So we've dealt with slope, and we've dealt with the y-intercepts. If you know the slope and the y-intercepts, then you can graph the line, right? So if we know slope and y-intercept, then we can graph the line. Line of a linear function, right? So let's say we want to graph y equals 1/2 x plus 3. You would say that the y-intercept is the point 0.03, and the slope is 1/2. And then you go over to the Cartesian coordinate plane 2 dimensions. And you say, well, 0, 3 is right here. The y-intercept therefore is there. And then the slope of 1/2 means change in y over change in x. So if the change in y is 1, and notice it's a +1 over a +2. So the change in y is positive, that means go up. Change in change in x is also positive, so it means go over to the right. So positive in the y direction means go up. Positive in the x direction means go to the right. And we end up at another point. Now, 2 points is sufficient to graph a line, but most of the time we just kind of keep that pattern up. Go up 1 to the right 2, get to your next point. Up 1 to the right 2, get to your next point. And you see the pattern. By the way, technically speaking, a +1/2 is the same thing as -1 over -2. So you could have gone down 1 and to the left 2 as well, and then down 1 and to the left 2, kept doing that kind of thing. You get the same line. That's all I'm saying. But there you go. So if you know the slope, the y-intercept, you can graph the line. Whenever you're asked to graph a function that is a linear function, it's the exact same thing. So let me graph -2x plus 5. Y equals, or f of x equals -2x plus 5. So the first thing I do is I say my y-intercept is the point 0, 5. My slope is -2. Now, here's the trick. Remember, slope always stands for change in y over change in x. If you don't have a denominator, you should view it as the number 1. So think -2 is the same thing as -2 over a +1. So there you can think of change in y over change in x. If I think of -2, you say, well, what's the denominator there? It's an implied 1. That's all I'm saying. Now, -2 over a +1, -2 in the y direction means down 2. +1 in the x direction means to the right 1. So we go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And we just keep that pattern up. There's our line. We're good to go. So if we want to graph lines, or in the homework, you won't have to graph it yourself. It'll say, here's a line. Which is the graph which one of these pictures represents the graph of that line? Okay, that makes sense. And by the way, we can do the reverse as well. If we have the graph of a line, let me share that. Now, this one just happened to be the same one, so I'm not gonna spend a lot of time that we did earlier. That's the point, but if we have the graph of this line, we can look and say, well, here's a point, or it goes through 0.05, so I know that 5 is the b in y equals mx plus b, or f of x equals mx plus b. And then another point, well, how did we get to it? We went down 2 and over 1, so the slope has to be -2. Okay. And you can do that for any line. So let's say I had this red one. What I could do is I could say, well, this red line goes through the point 0, -4, I can see that. So -4 is gonna be my B. And then let's try to zoom out. Here's another point it goes through. It looks like it goes through the point 4, 1. So we'd have to go up 1, 2, 3, 4, 5. And to the right, 1, 2, 3, 4. So because of that, it looks like my slope is +5 over +4. And my y-intercept is -4. So that means if you wanted to graph, if you had the graph of this line and you wanted to come up with the equation graph has slope. If we had to go up 5 in the y direction and over 4 in the x direction, right? And it also has y-intercept of 0, -4. We saw that visually. Then the equation well, depending on whether you write function notation, I'll write function notation. F of x equals 5/4 x should be -4 plus -4. Doesn't matter. So you can see those pieces visually on a Cartesian coordinate plane, then we can come up with the equation as well. If we have the equation, then we can look at those two features of the equation and then graph it on the Cartesian coordinate plane. Right. So slope and y-intercepts are really, really nice features to have. Okay. It allows us to go back and forth either direction, from the graph to the equation or from the equation to the graph. Now, another feature that most all lines will have, other than horizontal lines, every line other than horizontal line has, is that not only does this cross the y-intercept, but this is also gonna, let me rephrase that. Not only does it cross the y-axis at the y-intercept, but it's also going to cross the x-axis at an x-intercept. And lines are going to have unique x-intercepts and y-intercepts. I should say, let me rephrase that. a line has one x-intercept and one y-intercept. As long as it's not horizontal or vertical. So a line is going to cross the x-axis somewhere. And it's going to cross the y-axis somewhere, as long as it's not a horizontal line, because if it's a horizontal line, it would never hit the x-axis. And if it were a vertical line, it would never hit the y-axis. Right? We'll write a line down, never hit. So as long as we don't have horizontal or vertical lines, each line is going to have one unique x-intercept, one unique y-intercept. And guess how we find the x-intercepts and guess how we find the y-intercepts? Same way we always do, right? X-intercept found by plugging in 0 for the y. And just to recall, the x-intercept is always going to have the form x comma 0. Y-intercept is going to be found by plugging in 0 for the x value and it's always going to have the form 0y. This is exactly what we did with absolute value functions. So this should not come as a surprise. So if we said, let's find the x and y intercepts for, I'll use function notation, f of x equals -1/2 x plus 10. Which one do we want to find first, the x or y? Y is almost, we've been finding the y's all the time. So y-intercept 0, 10. By the way, that's why that b always has to be the y-intercept, because when you plug in 0 for x, this term goes away. And you're just left with the 10 or whatever the b happens to be, right? So that's why it always had to be the b. Now the x-intercept, we're going to plug in the 0 for the y. And then I have to solve for x. Subtract 10 from both sides in this case. And then divide by -1/2. Now, when you're dividing by -1/2, you could have also multiplied by -2. Dividing by a number is like multiplying by its reciprocal. So if you wanted to multiply it by -2, because that's a reciprocal of -1/2, go ahead. If you are dividing, when you divide, make sure when you type it into your calculator, if you're dividing a fraction, make sure when you type it in your calculator, the fraction goes into parentheses. The calculator. Okay. And then you should get a +20 as your x value. You can always check that by plugging it in and seeing that the 20 gives you out a y value of 0. So the x-intercept is going to be 20, 0. By the way, if you have the x-intercept and you have the y-intercept, and there are 2 different points, then you can also graph the line using these 2 points as well. Just plot the 2 points out and then draw a straight line between them. And you're good to go. So as long as the x and y-intercept are different, you can always graph by just finding those 2 points. All right, any questions about x-intercepts, y-intercepts? I don't even think we need to do any more. It's so straightforward, I think we'll just move on right through that. So we've graphed lines. We found x and y-intercepts of the line. The other thing that we're gonna focus on in this section is the concept of parallel lines. And then the concept of perpendicular lines. Let's start with parallel lines. What feature do 2 lines have if they're parallel? Same slope, exactly. Parallel lines, 2 lines are parallel. If 2 lines are parallel, it means they have the same slope. And then when you think about same slope, it means they're running side by side and never crossing each other. That's why that vertical line, we have a vertical line that doesn't cross the y-axis, so it doesn't, because the y-axis is our vertical axis. So it doesn't have a y-intercept. And a horizontal line doesn't cross the x-axis. So it doesn't have an x-intercept. But that's it. Parallel lines are 2 lines with the same slope, going in the same direction. Now, the other thing we're going to look at are perpendicular lines. So geometrically, perpendicular lines cross at right angles, meaning 90-degree angles. Okay, think corners of a square. And that also means since they cross at right angles, slopes are negative reciprocals of each other. So with parallel lines, we have the same slope. With perpendicular, our slopes are negative reciprocals. Now, I'm going to do this the geometric way. So geometrically, looks like right angles. Okay. And then let's talk about negative reciprocals. Let's take 2/3. Anybody know what the negative reciprocal of 2/3 is? What's reciprocal mean? Flip the numerator and denominator, right? So reciprocal means I flip the numerator and denominator. Negative means I change the sign, exactly. So 2/3 and -3/2 are negative reciprocals of each other. If we deal with something like -1/2, well, the reciprocal of 1/2 is 2/1, which is just 2. And negative of negative means I get a positive 2. And if I took something like a -4, the reciprocal of 4 is 1/4. And again, if it starts as negative, the negative reciprocal is a positive. So same slope is really easy. It's 3 and 3 here. 1/2 and 1/2. Negative reciprocals are a little bit trickier. Flip the numerator and denominator and then negate it. Now, I want to note many pairs of lines are not parallel and also not perpendicular. So they're neither parallel nor perpendicular. Okay, a lot of people, when I say, oh, here we're gonna look for parallel perpendicular lines, think every pair has to be parallel or every pair has to be perpendicular. That's not true. There's lots of lines that cross. So this one means that they don't cross, parallel lines don't cross. So they're gonna cross, but not at 90-degree angles. So we do this little game where we say, well, parallel, perpendicular, or neither. And we'll give pairs of lines, and we'll have to decide whether a pair of lines is parallel, perpendicular, or neither. So let's take the following lines. F of x equals 3x plus 4, and g of x equals 1/3 x minus 2. That parallel, perpendicular, or neither? Neither, exactly. One of the slopes. So these are neither. One of the slopes is a +3, the other is a +1/3. Now, those are reciprocals, but not negative reciprocals. And we need negative reciprocals to be perpendicular. We need the exact same slope to be parallel. So those are neither. Let's take another pair of lines. What if we had something like this? 2x plus 4y equals 5, and y equals -1/2 x plus 8. What would I do to figure out whether these are parallel, perpendicular, or neither? I guess we could graph it technically.
Simplify or like, switch things around.
Exactly, switch things around on this one. I would rewrite. Exactly. 2x plus 4y equals 5 in a slope-intercept form. So I'm going to subtract 2x from both sides, so I get the y on it by itself. We get 4y equals -2x plus 5, then divide everything by 4. Y equals -2 over a +4 is the same thing as -1/2. So now I see that this line, the second line I was given, has slope -1/2. The first line I was given is this one, also has slope -1/2. So these lines are parallel. They have the same slope. Oh, I'm sorry, I misdid that, didn't I? Doesn't actually matter, but that should have been a 5/4, not just a 5. I divided the first part by 4, I forgot to divide the second part by 4. So you can identify lines, even if they're not already in slope-intercept form, just put them in slope-intercept form, and then it's an easy, oh yeah, those are parallel, oh yeah, those are perpendicular, oh yeah, those are neat. Any questions about identifying parallel lines, perpendicular lines, or lines that are neither? Good. Now, for the last thing that we're gonna do in section 2.2. The last thing that we're gonna do is gonna be very, very similar to the last thing we were doing in 2.1. So I was debating whether to do it first or last, so let's do it last. Let's start finding equations again. Find the equation of a line that is parallel to some other line let's call it y equals -3x plus 4. And goes through the point 2, 11. Now that we know about parallel and perpendicular lines, this gives us another avenue to find equations of lines. That's the whole thing. Now, let's just take note. I'm given a line whose slope is 3. So when I want to go to find a line, what's my slope need to be? -3, exactly. If slope I'm given is -3, and I want to be parallel, so same slope as the one that's given. Parallel means same slope. And now, once we have that, it's the exact same process we've been doing. We know we're through 211, so we're going to plug in 211. Looks like I'm going through, well, looks like I have a B value of 17. So the equation of the line that I'm looking for is going to be y equals -3x plus 17. As long as I did all the calculations correctly, which I think I did. Parallel lines have the same slope, so we just use the same slope. Notice that this +4 part on the line I was given really didn't matter at all, did it? This could have been +43, would not have changed, or +45, or +146. Doesn't change anything. The y-intercept of this line was not used, in other words. So the y-intercept of that line, we only cared about the slope. The y-intercept didn't have any effect. And that's how parallel works, right? They're going the same direction, but we don't know how far apart they are. In the same theme as over here, let's find the equation of a line that is perpendicular to y equals 5x minus 13, and goes through the point 10, 28. Go ahead and try it. Give that a couple of minutes. See if you can do that on your own. Give you a couple minutes to do that, not very long. All right. So this one, in the same way, we're given a line, we only care about the slope of that line, don't care about the y-intercept of the one that I'm given, right? So the slope of the line that I'm given is 5. What's that mean the slope of the line I want to create is? Negative 1/5, exactly. So slope is negative 1/5, and I'm just gonna put in parentheses negative reciprocal. So I remember that. I got it from parallel line, or not parallel, perpendicular line, excuse me. So now we're off to the races. Y equals negative 1/5 x plus b. Plug in 10, 28. And then when I solve for b, I ended up getting a b of 30. So my y-intercept would be 0, 30. But the equation that I'm looking for would be y equals negative 1/5 x plus 30. Any questions about that? So we can use parallel and perpendicular to come up with equations as well. Now we've done every single topic in 2-2. It's a little bit, I kind of went a little bit out of order of how the book went over it, but the book starts with x and y intercepts, and then they do parallel perpendicular stuff, and then they do graphing. All right, so I wanted to graph first, and then x and y intercepts to do parallel perpendicular. But every single topic we covered. One thing I do want to make note of, and I haven't yet because you don't need this, but I'm gonna just give it to you anyway. Oftentimes, there is shorthand notation that you're gonna see for parallel and perpendicular lines. The shorthand notation for parallel is just two slashes going in the same direction. Right? So if you ever see that and it says // lines, it just means parallel lines. Okay. And perpendicular is an upside down T. It looks like a vertical line and a horizontal line intersecting. But usually you don't see that followed down, but intersecting at right angles is what they're trying to indicate. So perpendicular, upside down T, parallel, two slashes in the same direction. So again, I tend to just type it out or spell it out. I did that on my two examples here. But in the future, if you see that, that's what they mean. Any questions about 2.1 or 2.2? Right. Well, you have everything you need to complete those homeworks for 2.1 and 2.2. We'll do 2.3 and 2.4 next class period. That's more word problems. And there's something called regression that we'll do as well. But that stuff's pretty quick. So we should be able to get through both sections next time. Okay. All right. Well, I will see you all next time. Wednesday. This